VPN. This is our third video about MPLS. In our first video, we had discussed about MPLS in theories, and in our second video, using a simulator, we explained how this label switching works, and also we used Wireshark packet capture to analyze the packets, and we understand how this label switching works in depth. And in this third video, we are going to discuss about how the L2 VPN services are provided using MPLS. Okay, so as we know, MPLS is the service which is mostly offered by the service provider. Yes, also it is used within the corporate network, but most of the MPLS or services are provided by the service provider end. Okay, so when it comes to L2 VPN, it is mainly required when I want to have both the sites in the same network. Say, for example, I have a site A and site B. It might be in a different geographical location, but if in case I want to have both the site in a same IP segment, say for example, let it be some /24. If I want to have both the sites in the same /24 network, then in that case, I'm going for L2 VPN. The reason is the service provider will be giving only an L2 connection and nothing more than that. Okay, so and as this is an L2 VPN, they are not managing our routes. They are not going to route the networks which we are using. So they are simply going to provide an layer 2 connection by which it act a kind of a point to point. Okay, point to point. It acts as like an directly connected devices, but it's not. It's an point to point tunnel. Okay, so this is how it works, and this is where it is required, the L2 VPN. Mainly it is required when different site uh, want to be in the same network and they are in a different geographical location. Okay, so this is where mostly people will go for L2 VPN. And let's see, so before starting that, as we discussed earlier, in order to establish an MPLS network, first we would like to have, we need network that is established by the routing protocol, because MPL, we cannot establish an MPLS network without a routing protocol. So in this setup, I'm using EAGRP in this network, and I'm using RIP for connecting site A and site B. Okay, so in order to minimize the time consumption, I have also already configured the EAGRP and MPLS for these three routers, and I also configured a RIP in this router. So now I'm going to show how we need to configure MPLS in this router, and also I'm going to configure a RIP, and next then we are going to configure the L2 VPN. We are going to form L2 VPN between site A and site B. Okay, so L2 VPN is nothing but it's a kind of point-to-point tunnel. Okay, so once we finish the configuration, a point-to-point tunnel will be formed between this interface of this router and this interface of this provider edge router. So whatever traffic that comes in, all the traffic will be sent through this logical tunnel over this router to this particular router. So as we know earlier, as we discussed earlier in the first two videos, here in MPLS, the packet will not be routed based on the IP address in the routing table. Instead, here the packet will be moved from one hub to the next hub using the labels, right? And also when the packets are switched to the LSR, that's the router in between the egress and the ingress routers, the labels will be swapped based on the labels that is maintained in the neighbor router. That's how it works in the MPLS network, right? But in a L2 VPN, once a label is pushed in this router, it will be directly sent to this router. There is a logical tunnel formed. Okay, this is a kind of two labels. Okay, two labels will be used. I mean to say, in a general MPLS network, one label will be sticked on the packet, but here in the L2 VPN, uh, over that label another label will be sticked, and it will be directly passed through the this router. So none other no other routers in between this two edge routers will open it. Say for example, if any packet that comes through this interface, this router will stick a label and it will directly send to this router. So all this this P1 or P2, this router won't see the labels, or they are not going to swap. They are not going to do anything. Okay, this packet will be directly sent to this router through the logical tunnel, and it will be going there. So that's the reason we are saying it's a point to point connection. It's a point to point tunnel. Okay, let's start the configuration. As I said earlier, I have already configured IP addresses, okay, and EAGRP routing protocol, and I also configured the MPLS. So let me show. This is P1 router. Let me minimize it. It's fine. Okay, I think it's fine. It will be better. Okay, so this is a P1 router. Okay, where I have already configured the IP address. Show IP interface brief. If you see, I have already configured the IP address, and also I have configured EAGRP routing protocol in this router. EAGRP. I used autonomous system 100. Okay, so all the routers in this particular network will be in the autonomous system number 100. You see, I have already configured EAGRP, and I also configured MPLS. If you see, labels are generated for the learned network using the EAGRP routing protocol. Okay, so this routers, the configuration part is done. So now what we are going to do, and for this router I have configured IP address and the RIP protocol. Okay, because this site A and site B is going to be in the RIP connection, right? The RIP protocol. So if you see, I have configured IP address, the loopback IP, and the interface IP. Show IP route. Show IP route. If you see, there is no, it has not learned any other route, external route, means it learned only the directly connected routes. Okay, so I'm coming to site A. Let me finish the RIP configuration. Okay, site A. For your reference, I'm showing there is no configuration routing. Show IP interface. Okay, IPs are not configured. So first, let me configure the IP. I am at site A router. So this is customer rich router. First, I'm going to configure loopback IP address, which is 1.1.1.1 subnet mask 255.255.255.255. Okay, and the next is gigabit Ethernet 0/0, and the IP address for it is 192.168.10.1. Okay, let it be in 20/24 network. Okay, as I want to have some simple routing protocol, I'm going to configure RIP. Okay, version 2 network 1.1.1.1. Okay, network 192.168 10.0. Okay, one more thing, I just want to verify here. Okay, 10.2. That's fine. Anyway, it's RIP. Okay. So the configuration part for both this router is done, and remaining these routers are done. The only pending thing is here. So first thing, I want to configure the IP address. Then I want to configure the routing protocol, and over the routing protocol, I am going to configure MPLS. Okay. And so the first one is interface loopback IP address is 50.0.0. Sorry, 50.001.255.255.255. So this is the loopback IP address. And one more important thing, there is no IP address for the interface which is connected to the user, right? Okay, so I'm configuring IP address for this interface, gigabit Ethernet 0/0, and the IP address is 10.0.0.1. It's a /30 IP address. So 255.255.255.252, and I'm giving no shut. Okay, that's it. So now interface configurations are done, IP configurations are done. show IP interface brief. Yeah, it's done and the ports are up. The next thing is we're going to configure the routing protocol. As I said, we are going to configure EHRP because it's running in the neighbors, the other routers in the service provider networks. Okay, and it's using autonomous system 100. There's some spelling mistake. Okay, and I'm going to advertise all the directly connected network. First one is 50.0.0.1. As it's a EHRP, I need to give the wildcard mask 0.0.0.0.0 because it's a /32 IP. And next one is network 10.0.0.0 and it's /30 network. The wildcard mask is 0.0.0.0.3. Okay, summary. That's it. Now EHRP configuration is done. So if you see, we are seeing 10 network, it's directly connected, 20 network that's learned through EHRP, 30 network is also learned through EHRP, 50 it's directly connected, nothing but the loopback of the own router, and 100, 150, 200 is the loopback IP addresses of the other rest of routers in the service provider network, and everything is learned through the EHRP. So if you see, it's learned D, right? D is nothing but the EHRP. So our routing is working. So now we are going to configure the MPLS. Okay. So first thing is I'm going to in order to enable MPLS, it's only one command, that is MPLS IP. And also, if we want to manually give the range for the MPLS labels, that's the command for that is MPLS label range is, I'm going to specify all the labels that is generated from this router should be in the range of 100 to 199. Okay, as like the same, I have specified 200 to 299 in this router, 300 to 399 in this router, 400 to 499 in this router. Okay, so now I'm going to configure MPLS. In order to configure MPLS, I need to give the command MPLS IP in the global configuration mode. That's it. And then I need in the interfaces, I'm going to run the MPLS configurations. So interface gigabit Ethernet 0/0. Uh, Within that, I'm going to call MPLS. That's it. Now we are calling MPLS in the interfaces also, and there is no need to configure MPLS IP in the loopback IP address because it will be automatically taking it. Okay, and so let's check MPLS forwarding table. Yeah, it start to generate the labels, and it has generated label for all the network that is learned through the EHRP network. Okay, EHRP routing protocol. Okay, popping up is nothing but the network which is connected in the neighbor router. It's a popping label because there is no label generated in the neighbor router for that, right? Because it's directly connected to that router. Okay, so yes, now now the MPLS is formed in this network. Okay, in the service provider network, the configuration is done. If you want to test, we can test it. Trace route. Mean to say, I'm from this edge router. I'm going to reach the loopback IP address of this edge router 200.0.0.1. Okay, 0.0.1 from the loopback IP address is the source. Okay, so if you see, first two hops it's using the label switching, and the next hop, as it's directly connected, it's going with the IP address. Okay, so it confirms us that MPLS is working. Okay, so now the MPLS network is built here also. And one more thing, if you see, there is no labels or there is no information about the L2 circuit or the point-to-point tunnels. Okay, and also if you see for the 200 network, we have the label 104 that is generated. Okay, that's fine. Let's hold on here, and as the MPLS is built, let's just check. It won't work. Just to show you, if you try to ping 2.2.2.2 from site A, it will not, because it is running RIP and it is running EHRP. We are not redistributing, or we are not doing any advertisement, because they are giving only L2 connection, right? So now the MPLS configurations and the MPLS setup is done, and here this setup is done. What we are going to do, we are going to form a tunnel between this interface in the router to the this interface of this router. Okay, basically it's a point-to-point tunnel. What we are going to first to do, we are going to first create a pseudo wire in this router. Okay, as like the same, we are going to create a pseudo wire in this router, and with that we are going to form a tunnel between this both router. Okay, it will form a logical tunnel through this network. So whatever traffic that hits through the interface, it will be going through the logical tunnel. Yes, it will be having a label placed, but it will be going directly to the this edge router using the logical tunnel. Okay, and none of the routers in between will open the package, or it will not see any for any labels. Okay, because it's going via the tunnel. Okay, so let's do the configuration. So in order to configure it, first what I'm going to do, in site A, I'm going to create, and one more important thing, this tunnel is configured using the virtual circuit. Okay, let's see what is virtual circuit also in detail going forward. So first thing is we need to configure the pseudocode, as I said, and you can give whatever name you're creating a class name for it. Okay, in the pseudo, as it's a layer 2 connection, I'm giving layer 2 link. Okay, and it's coming from site A. So this is the pseudoware class I'm creating, and I'm encapsulating it, saying that all the traffic should encapsulate, MPLS encapsulation. Okay, that's it. Then what I'm going to do, I'm going to that interface which is connected to the uh, site A, okay, which is connected to the customer. Okay, in that interface, I'm going to form a tunnel. As I said earlier, I'm going to form a tunnel from this interface of this router to the this interface of this router using pseudo wire and the VC. VC is nothing but a virtual circuit. Okay, because as I said earlier, this is an edge router and this is also an edge router. According to this customer, it is only one tunnel, but this service provider might have given n number of this MPLS L2VPN, okay, using this network. Okay, in order to differentiate it and in order to segregate the traffic in each tunnel, we'll be forming a virtual circuit for each individual tunnel. Okay, using that circuit, this tunnel will be formed and the traffic will be flowing. Okay. So I'm getting into this interface where the customer site A is connected. Going there, using the command xconnect, I'm forming a tunnel with the loopback IP address of this particular destination edge router, which is nothing but 200.0.0.1. Okay. If I put question mark, it will show the VC area. I told right the virtual circuit. This is what the virtual circuit is, and the number it can ranges from 1 to this much, but still it depends on the hardware. Okay, before we are going for the VC circuit, we need to make sure that the capability of the hardware, how much VC it will support. Okay, so it can be whatever it is, the number I can give here 100,000. It's not that as I'm creating the first circuit it should be one. No, I can directly go for 100 also. This is just a number. Okay, but one thing is we need to make sure that whatever the number created this side should be the same on the other side also. I mean to say, if I am creating one virtual circuit in this router in this interface, the same should be same, and the virtual circuit should be same in the other end. Okay, here also. So I'm just having it's like 100 as the virtual circuit. Okay, and I'm calling that pseudo wire class which I have created here. So it's L2 link from site A. Okay, I'm calling that here. That's it. So if you use the command, so this side configuration is done. Still we need to do the same on the other side also, but before that I would like to show you one thing about the virtual circuit, the tunnel. Okay, show MPLS L2VC. The tunnel number, the VC number is 100, right? Yeah, it will show the status of the tunnel, the status of the virtual circuit. Okay, okay, it's in admin down. Usually admin down saying that the physical interface is down. Okay, show if I see 10, yeah, the physical interface is still down. Let's unshut it. No shut. Okay, yeah, if you check now, it will say the tunnel is down. Okay, see the status, it's showing us like the circuit is down. Okay, and it will give the information as like in which port the VC is starting from and what's the destination IP address, like that. And also we can see it in detail. Let's see once this tunnel is up. Okay, so the reason it's showing down is we have configured only one side and not in the other side. Okay, also if the VC number is different, then it will show down. Okay, let's go in the this edge router at side B. I'm going to configure, as already MPLS is enabled. I'm directly going for the L2VPN. First I need to configure the pseudo wire class. Okay, I'm giving L2 link, and it's not that the pseudo wire class what you're creating in this router should be same as like here. No, it's not that, and we can have a different name as well. Say for example, if I'm for this site, I'm creating for us like site B. Okay, and I'm doing encapsulation. Okay, and then I'm going in that interface gigabit Ethernet 00, and I'm forming an Xconnect. Using the command Xconnect, I'm forming a tunnel from this interface of this router to the this interface of this router. Okay, and what is the loopback address of this router? It is 50.0.0.1. And as I said earlier, we need to specify the VC number. Okay, the VC number what we specified in the other router is 100, so it's 100 here also. If we keep one or other than 100, whatever you keep other than 100, it will show the VC down. The VC never come up. Okay, so I'm giving the same VC number here, and I'm calling the pseudo class what I have created earlier. Okay, okay, that's it. So the configuration for the L2VPN is done from the provider end as well. So if you see, once we did the configuration, then the new neighborship is formed. Okay, using the point-to-point connection. You see, let's check the MPLS L2VC 100. See, now the VC status is up. Earlier, when we checked in edge router of site A, it showed down, right? So immediately once we configured the X connect at the provider edge router at site B, it came up. And let's use the same command again. It will show us up. See, it will show us like up. Also, as I when we checked earlier for the forwarding table, the MPLS forwarding table, we have not seen any labels that is generated for the L2 circuit, right? But if you see, a new label is generated for the L2 circuit. So this is the reason I said this is a kind of two labels, because for the normal operations, the normal label switching, when it goes from this router to this router, user it will go through the say for example, in normal, if any other packet that comes from any other customer or any other network that is connected from this router, let it be some other network that is connected from here, and if it want to reach to 200 network, when it comes to this router, it will make use of the label 104. But in case if site A want to communicate to site B, when it comes here, right, it will make use of the label 105. Though the destination, the edge router of the remote site is same, it has a different label. Okay, it is a label over label. Okay, so whatever traffic that is coming this way, it will have a label 105 pasted, and it will be directly going using the logical VPN tunnel. So this is how. And also, I'm sorry, it will not paste label 105, it will paste the remote label. Okay, let me show you what is the remote label. So MPLS L2VC 100 detail. Okay, so in the detail command give us the details about the VC, as like what is the IP address and the VC circuit ID, and which interface it's called in, what is the next hop, the interface ID or the next hop IP address, and LDP informations. Okay, and I want to show some interesting factor here. Yeah, this is here. See, it has a different labels. for this particular circuit. So it's saying that 105 is the local label that is generated for the circuit, and the remote label is 405. So any traffic that is coming from site A, label 105 is ticked, and it will be directly going to the through the logical tunnel built over the MPLS, and it will reaches this site. Okay, and there is no swapping and all done by this routers in the middle. Okay, so this is how it works. And if you see in this router, for the details command, we'll see the remote label as 105. See, because when we check from site A edge router, it shows the remote is 405, and when we are checking in the in this router, it's showing the remote local is 405 and the remote is 105. Okay, so this is how it works. Let's see. And one more thing, now as we have configured this tunnels, now when we try to reach site B from site A, it will ping. So earlier when we try to reach right, it doesn't work. So the success rate is 0, but I am trying to reach now. It's not working. Let me check what's the reason. First, let's check whether the physical interface is up. Yes, physical interface is up. Okay, let me check here. It should be up. That's the reason we get the VC is up. Let me also check in this. It is up. Okay. Yes, now it's reachable. Earlier it was not working. Then it starts to work. Okay. Because the other physical interface on the other side was down. I just shut it and unshut. Then it came up. Show IP route. Okay. So from this router, okay, from site A, when I'm checking for the route, I could see the network from which is configured in the site B. It's learned through RIP. Okay, so this is the beauty of this, because we have not advertised any of this RIP network over the AGRP. Sorry, over the the AGRP network which is running over the MPLS, which is running over the service provider. But if you see, we can able to get this site A is getting the route information from site B. Okay, so this is the beauty of it. This is how the L2VPN works. Okay, just like the same, let's check it site B as well. Show IP route. Okay, yes, it had learned the IP address, the network from site A. Let's start ping 111.1. Yes, it is pinging. And let's do one thing. Let's do a trace route from site. I'm sorry, this is provide the rich router. Okay, okay. Let's do a trace route from this site, this customer rich router to this router. Okay, trace route 2.2.2.2. So see, actually the packet is going through this much routers, this 4 routers, and reaching the site B router. However, when you're doing your trace right, it is reaching the destination in one hop. So this is how it is. It's confirmed that it is giving a point-to-point connection, right? Because as per this, as per the site A, it is directly connected to site B. Because when we are doing a trace route, right, it is reaching the destination in next hop. Okay, though the packet travels through this 4 routers, it is a point-to-point tunnel. Okay, it is a kind of directly connected. That is the reason it is showing like it's a point-to-point. Okay, it's a point-to-point tunnel. Okay, so this is how this L2 VPN works. uh, Whatever traffic that is going, I'm sorry, whatever traffic that is coming in the interface which is connected, which is given to the customer, a tunnel will be formed to the peer side. Tunnel will be formed to the other edge router at the remote side, and all the traffic will be going through the tunnel, and it will be reaching it. It's a point-to-point tunnel, okay, over the MPLS. And also, I'd like to show you the other thing. Let me, let's do one thing. Let's capture the traffic between this interface, okay, and see what it happens when we try to ping from this side to this side, okay. Because I would like to show you that when we are using this point-to-point tunnel, it's using two labels, right? So let's see that. Mhm. Yeah, it starts. Okay, so we are capturing the packets between P1 and P2. Okay, which is within the service provider network, and from site A, we are going to initiate a ping towards site B, and let's see what happens in the trace in the packet capture. Okay, so now from this router I'm trying to reach this router, okay, and one before that we are using a RIP only within this network, okay, and not here, and we are not redistributing or we are not advertising any of these routes to this network, okay, and here they are completely using EAGRP, right? So I'm initiating ping. Huh. I'm sorry, I'm initiating from the provided edge router, which is here by mistake. Okay, I'm sorry. Let's initiate from here. That is from site A. I'm initiating ping. Okay, from here. Here we are getting response. Okay, let's check the packets we captured. Okay, and we are sure that we are using only EAGRP in this network, and we are not using RIP over here, and we are using RIP only here. But if we, when we are capturing the packet, right? If you are searching for the RIP, we can see the RIP packet. See, both EAGRP and RIP. EAGRP. Sorry, first we need to show you RIP. See, now we can see RIP version 2 packets, which is not configured in the provider router. And I would like to show you one thing. When you're looking for the IP, right? See, it's nothing but the interface IP from site A, which is 192.168.10.0, 10.2. But when you check for the destination, it's not giving you the destination IP address of 2.2.2.2. Instead, it's giving us the multicast IP address. Okay, and yep, it shows you the two labels. One is the normal label, which is used for the communication between the provided edge router, this provided edge router to this provided edge router, and the other label is which is generated dedicatedly for the VPN tunnel. Okay, so if you see here, I can show you again. Let's put that until that we can stop. Okay, so as we showed earlier, 105. 105 is the label that is generated in this particular router dedicated for this L2 circuit, right? See, this is 105, which is dedicated for the L2 circuit, and this 200 is nothing but the other label that is generated, okay, for that particular network. So this is how MPLS works. So even if you are not configuring EAGRP, sorry, even if you are not configuring a RIP in this network, but still this RIP packet goes within the tunnel that's formed in the EAGRP network. Okay, this is how this L2VPN works. Hope it's useful to someone. If it's really helpful, please like the video, share with your friends, and subscribe the channel. Thank you for your time. Thank you for watching. Please support.